So yeah, we had designed the board layout yesterday, and this is our design. Now, how these components are coming in this area. So you all are must aware that there is a icon named Update PCB from Schematic. This is the only icon which will load your generated schematic, generated net list which you had generated while making the schematic. So just click on this. Sorry. Yeah, you have to first load the netlist. You have generated the netlist in this. Yeah, you had generated here the netlist. You had generated that netlist and saved that netlist in your folder. Now in this you have to load the netlist. It will load all the components with all their connections. First, I should delete all this. Yeah, just load the netlist from here. Click on the load netlist and just find the location where you had saved this netlist, photo level indicator netlist. Just double click on this and update the PCB. Click yes. Are you sure want to update the PCB? Yes. Then close. Here all the components are placed in your randomly placed in your design layout. Now you have to place all the components in a systematic order. Like just at play, I placed all the components in the systematic order in like this way. Yeah, this is the battery barrel jack. This is your transistor Q2. This is your Q1. I am just moving these symbols just by placing the mouse and the pressing key on your keyboard. This is Q4. This is Q3. Try to place your component as near as possible. Like let's take an example. If a transistor is close to this R5 rather than this D2, so first place R5, then place D2. This will uh, this in the you if you do like this, then your signal traveling time will be the less, which is the most important thing. So now I will be doing this resistance. Just rotating this resistance by clicking on R. This R2 resistance is this resistance. So the one terminal of this resistance is connected to the second terminal of transistor, and the another terminal of resistance R2 is just placed in the border. So we had placed such like that we can drop the wire in somewhat here. Now it's time to put the LEDs, these LEDs, D2, D1, D2, D3. D1 is connected to this. D2 is connected to this, and D3 is connected to this. And here is the buzzer terminals. Just place the buzzer terminals here. Now our parts placement of all the parts are done. Now it's time to do the routing in our system. I choose the front copper layer. F.cu is your front copper layer. B.cu is your bottom copper layer, or your back copper layer, or the copper layer which is used in the bottom layer of the PCB. Like there are two layers in the PCB. This, like I'll show you in this. Yeah, this is how your parts are placed. This layer is your top layer or front layer, and this layer is your bottom layer. So for this, we will be using F.cu route tracing, and for this layer, we will be using B.cu routing. So I choose, this is the route tracks, this is the via. I'll tell you how vias work. This is your add field zones. I'll be choosing this first, F.cu, like front copper, and connection all the possible ways. Now you can see one thing. This is the all possible ways I can put the F.cu tracks on the top layer. Now I won't able to connect this because there is already a pair of wire on the top layer, and we won't able to cross this line. So we have two options. Either we go through this size of location, or we can change the layer. For this, we just have to put our cursor here and just right click on the cursor and just choose place through via. Here the via will place like this, and you can automatically transfer into the bottom layer. You can see here, I don't even want to change this to the B.cu. It automatically changes to B.cu. So now we can do this. Now again, we can cross these two lines, but we won't able to cross the red line over red line, or green line over green line. We can transfer the lines green line over red line, or red line over green line. Red line denotes your F.cu, which is your layers or tracks on the top layer of the PCB, and B.cu denotes your layers on the bottom layer of the PCB, tracks on the bottom layer of PCB. And one more important thing which I want to tell you, all the tracks are done. So here it is written that unrouted. Unrouted means there is no unrouted parts in your schematic or in your design layout. So it is written at 0. If I'll cut one of this line, so yeah, it is written that because this connection is now disconnected, now it is written that unrouted is equal to 1. So we have to connect this line to make unrouted is equal to 0. So one more important thing I want to tell you, that we are not allowed to make connections like this. Like, yeah, like this is the 90-degree connection. The 90-degree angled connections are called as the bad connections in PCB designing. Why? It is not bad connections in PCB designing for low frequency circuits. These are the low frequency circuits, but in high frequency circuits or high speed circuit designing, 90 degrees are the worst cases, because if the signals come from this horizontal side and go through this vertical side, then due to high speed of that signaling, there is an acid trap at this corner. Due to this acid trap, this wire track will burst at any time of the signal throwing. So try not to make 90 degrees. Just try to make no 90 degree in your PCB designing. Like, you can make the acute angles, you can make obtuse angles, but do not make 90 degrees. So yeah, it is done. The connections of all the PCB is done. And now one more thing I want to tell you. I just discussed about the current across the width of the this trace. Like, the current flowing through this trace is equivalent to the width of this trace. So for current throwing, the output current of this transistor is like 100 milliamps. So we for 100 milliamps we have to use 0.5 mm. This is a table already given on the Google. Just type current directly proportional to the trace width of PCB. It will present you a table. So for this, I have to change all the connections, all the output connections of the transistor. And output connections of the transistors are this. These are the output connections. This is the output connection. This is the output. This is the output. This is the output. So output connection is, I have to make these output connection as 0.5 mm trace width. I have to change it to f.cu. Yeah, it is done. And if you are using a 9-volt battery, so the 9-volt battery will allow a current of 400 to 500 milliamps to cross through the PCB. So for this, the input trace width must be 1.00 milliamps. So I have to replace all these 0.250. This is a 0.250 width of the trace. So I have to change all these widths to 1.0, because this is the input volt and this is the ground. Now input connections are also done, output connections are also done. So now I have one more thing I have to tell you. This is the route tracks. Again, I am telling, just note it down. This is the route tracks. This is the add vias. This is the add filled zones. Now I'll tell you what are add fill zones. Add fill zones, if you are remember my our first session, we had discussed the ground planes. I tell you, the ground plane is as much as possible. It should be as large as possible, and it should occupy every corner of the PCB except where there are signal lines. So this signaling lines, one thing I had left, yeah, R1. So I have to make these things. Yeah, R1 is this, and this is this. See. Okay. R2 is this, and R1 is equal to this. And the fourth line is coming from this transistor. Now you can clearly see that while making this, there is a 90-degree. So I have to remove this 90-degree. Now 90 degrees removed. And the fourth is directly from the buzzer second terminal. Yeah, from here. This is the longest wire. So yeah, now it is done. Now I'll put the ground plane of this. For putting the ground plane, just click on the add fill zones. Click here and just select which layer you want to make the ground plane. I am making the top layer as the ground plane. So I am choosing the f.cu and click on this net GND and start making the ground plane. I'm just now I am just making the roughly, then I will systemize that thing. I'm just making a little bit beautiful. This is the unfilled zone. Now I have to fill this zone just by clicking the B button. And if you want to make the unfilled zone from filled zone, then you have to just click the Control plus B. I'll just write these things. Yeah, now it is done. Now I'll go to view. Now, yeah. Now I just want to place like the whole thing. Now I just press the B button and now you can see the red part of this area. Now this is the red part. The red part is the ground plane. And now I place all the ground plane and now my PCB is done. Now you can save your PCB and you can see the 3D view of the PCB. This is how your PCB will look like after the production. Like this is the buzzer terminal, this is the LEDs, these are the resistances, these are the transistors, again these are the resistances, and this is your barrel jack where you will put your 9-volt battery. And again I'll tell you, this is your add graphic polygon, and this is your add graphic arc, this is your graphic circle, this is your graphic lines or to make any type of polygon, or this is your add fill zone with the help of which I had made the ground plane, or you can also make the power plane if you are making the 4-layer PCB or 6-layer PCB. This is the add via. One way I told you how to add the via, just by clicking on right click and just place the via. The another thing is you can just click on this and just put the via like this. And this is the routing tracks. If you want to make a connections or making the tracks, then you will choose this line. This is f.cu is your front copper layer, this is your back copper layer or bottom copper layer, or it is also known as the top copper layer. The edge cuts is the only layer with the help of which I had made this uh, boundary, or you can say the board layouting I had done yesterday using this edge cuts. So yeah, this PCB is done. Now, if you want to ask any question, then you can ask.